Alrighty, here's an eDoctrina assignment that will be available to you. It's called Proof Examples. I'm on question 1 here, even though it says example 2. And this equation editor is different than the one you've been using, but I think that you'll find it's more intuitive. If you need help with some of the coding like we've been doing in class, like in Google Docs or Kami, you can click on this and it'll show you all the shortcuts, like doing backslash overline and being able to do something like that. So, on to the actual math. Down here you'll have your givens, you'll have your proof, and you'll have your diagram. This box should be used for drawing on your diagram. You should be drawing on your diagram. You should be making that as a tool that is available to you. So, one thing you're going to notice about this video, in order to make it short, is that I'm going to pause, type some things, and not just show the video while I'm typing. So it's going to be a little bit jerky, but again, be looking at the structures that I'm using. So, where you should always start with proofs is by using your givens. So my first given, put the number 1, my first given says that angle K is congruent to angle M. Okay, so that is my first given, and I'm going to write given. Then, my theorem, I can tab over. I should be able to tab over. I can't. Okay, so my theorem is I'm going to see that I have two congruent angles. So once I have two congruent angles, I can come down here, kind of put the theorem to the side for now. And I'm going to draw on my diagram that angle K is congruent to angle M. Now we've been talking about isosceles triangles since Unit 1, so you should recognize that this is an isosceles triangle. Once you do that, you should go to your definition sheet, and I have it over here, and try to find an isosceles triangle. Oh, there's an isosceles triangle. I have two congruent angles, and here's my theorem. I can copy this theorem, which says that if the base angles are congruent, that means I have an isosceles triangle, which means that I have the sides congruent. So I can copy this theorem and put it into my equation editor, and then I can write my conclusion. So as you can see from your definition sheet, the conclusion was that the sides were congruent. I can't use these letters because this triangle is different than the one I'm working with, but I can use that same idea and say that, okay, the sides across from these angles are congruent. So, pause. So as you can see, I have my given, my theorem, and then my conclusion was that those sides were congruent, so I can now mark them congruent. So I do given, theorem, conclusion, draw what's congruent. I've squeezed everything I could out of that proof, or out of that given, so now I go on to my next given. And our next given is that LJ bisects angle KJM. So I see that LJ is a segment and it is bisecting this angle. So I've got an angle bisector. So you should pause the video and go to the definition sheet and find the theorem that goes along with an angle bisector and see if yours matches mine. So there is what your theorem should have said. It is right here. Theorems that can create congruent angles, angle bisector. Looking for the word angle bisector. I found it. Come over here, copied, pasted. For my conclusion, it is that we have two congruent angles, KJL and MJL. So I wrote my conclusion and then I drew on my diagram. And our goal this whole time was to prove these two triangles congruent. If you want, you could highlight the triangles like this. So there's my two triangles, and I can see now that I have an angle, a side, and then an angle congruent. So for my last step, step 3, my theorem is going to be that angle side angle is congruent to angle side angle, and therefore we have congruent triangles. And so our conclusion with that is that we have triangle JKL is congruent to triangle JML. Okay, so that's how you do a proof. Again, it's given, theorem, conclusion. Given, theorem, conclusion. Until the end where it's just theorem, conclusion. I'm drawing on my diagram, and the way I know what given to use is that I'm using the givens in the order that they're given me. You can also just check them off as you're going. So you could, I use that one, use that one. There we go. And then I proved it. So I can check that and give a smiley face. Okay, so the next one, it'll be a little bit more of a difficult proof, and but it's the same structure. So watch that one.